Modified Gaussian integral 4. This is basically the fourth video on my series of modified Gaussian integral, and the modified Gaussian integral up here supposed to be in this form: e to the power minus x square fx dx going from 0 to infinity. Till now I have on the other three videos, like I used fx as x to the power n, sin x, cos x, and these functions. And in this video I will use the ln of x, and this one is somehow easier than the others, though others were also pretty easy. Yeah, but this one is, and I can only solve easy problems actually. Fine. Now let us see how do we solve this. First of all, let's try to change this to the gamma function kind of thing by substituting y equals to x square, and that will make things simpler. Integral from 0 to infinity e to the power minus y ln of x is y to the power 1 by 2, and then dx is basically x is y to the power 1 by 2, so that's why dx is 1 by 2 y to the power minus 1 by 2 dy. Yeah, now take 1 by 2 outside, and also from here also 1 by 2 comes in the front, so 1 by 2 times 1 by 2. Integral from 0 to infinity e to the power minus y ln of y to the power minus 1 by 2 dy. Now this is a standard integral, and there are some standard ways to solve this. I'll share about it. And first of all, let me write it in a proper way, then I will share the way that all people solve it, this sort of integrals. Yeah. Now the standard way is, we have this thing, integral from 0 to infinity e to the power minus y t to the power sorry, this should also be t, and then t to the power x minus 1 dt. This one is the gamma function. Now if we differentiate this gamma function with respect to x, yeah, the differentiation will go inside the integral, because the integral is in the world of t, and here that will be a partial derivative with respect to x, which gives us integral from 0 to infinity, and this will be just a constant, and over here that will be t to the power x minus 1 times ln of t, because t is supposed to be a constant when differentiating with respect to x. Now if you just substitute x as 1 by 2, you get integral from 0 to infinity of e to the power minus t to the power minus 1 by 2 ln of t dt, and this is exactly the integral that we want, isn't it? Yeah, what a beauty. Now how to find the gamma dash of 1 by 2? Yeah, now for this we will take the help of digamma function. We know that our digamma function is defined as gamma function gamma dash of x by gamma x. Yeah, that's why this will just be gamma 1 by 2 times digamma 1 by 2. And how to find gamma 1 by 2 is well known as root pi. How to find digamma 1 by 2? For that we can use the duplication formula of digamma function, that is, I also don't know right now, wait, let me see, but we can find this. Okay, so our duplication formula of digamma function is digamma of m plus 1 by 2 is 2 times digamma of 2m minus digamma of m minus 2 ln 2 minus 2 ln 2. Yeah, using this duplication formula you can basically find digamma 1 by 2, and so that gives us digamma 1 by 2 as minus of Euler-Masonic constant minus 2 ln 2. Yeah, I have already did this in one of my videos, and you can check in my channel or in YouTube as well. There are videos from, let's say, mathematics mi maths 505, where they have found the value of digamma 1 by 2, and this one is a well-known thing. Yeah, I think you have already known this, or you can look up on YouTube as well. And ln of 4. Now we have this thing, so gamma dash of 1 by 2 is here. Yeah, now there's nothing much to do. 1 by 4 times this is gamma dash of 1 by 2. Substitute the values of gamma dash 1 by 2. 1 by 4 times minus root pi Euler-Masonic constant. This is Euler-Masonic constant. Yeah, please note that, plus ln of 4. Yeah, and now I think we have the answer. The answer for this is now comes to be minus root pi by 4 times power of 4. Euler Macedonian constant plus ln of 4, and that's the answer. Yeah, and yeah, now we have the answer. That matches. Yeah, okay, that matches, and it's solved. So talk about the flow of this problem. So basically we started with trying to make this gamma function kind of thing, and we got a log over here, like which we could get from a gamma function itself if we partially differentiate it with respect to x. Yeah, we can get it here. Now we then found that this is actually gamma dash 1 by 2, and to find that we used gamma and digamma. Gamma 1 by 2 is known, digamma 1 by 2 can also be found from this formula. Yeah, and then we have this answer per gamma dash 1 by 2, which when substituted we got the answer. That was it. Hope you enjoyed the video. Thanks for watching. Look forward to seeing you in the upcoming videos too.